Hello, I'm Anna Mackay. Thanks for joining me again. Today on the menu we have cubic equations and how to solve them. So a cubic equation, as a refresher, is in this form and a, b, c, d are constants. If a was equal to 0, what would happen? This term would disappear and therefore our highest power of x would be 2 and therefore it would be a quadratic, not a cubic. So that's why we write a is not equal to 0. The steps for solving these: rearrange the right hand side to equal 0 if it's not already done. And using a given solution, you can factorize the left hand side into a linear and a quadratic factor. And then you'd need to use factorization or the quadratic formula to find the remaining solutions. Let's put that into practice. So if you're told that x equals 3 is a solution to this cubic, find the remaining solutions. So just a reminder that what does it mean to be a solution? It means that if you were to substitute x equals 3 into this, the whole thing would equal 0. So that's one of the zeros, if you like, of this. So what do we do with that? So being a factor of 3, we can write it as, being a solution of 3, we can write it as a factor like this. And therefore that can be paired with a quadratic of some form, and then that together will equal r cubic. So what would the quadratic look like? It would be ax squared plus bx plus c. So you'll start to get quicker at solving these. So technically you'll be able to jump straight to writing that quadratic with your a and your c. I'll talk you through how to do that. So to solve for our a, we need to work out what our x cubed term would be. And so that would come from the ax squared and the x term to give us ax cubed, and then equating that to the x cubed term over here, a would have to be 2. So you'll start to recognize that quickly and you can jump straight to that. Your c term is your constant term, and the places that could come from are the constant term here multiplied by the constant term in the first factor to give us -3 times by c. Equating coefficients, that will be equal to 36. So essentially, when you write that quadratic out, you ask yourself, what do I have to times -3 by to get +36? So noticing that the two negatives there, in this case, it has to be a negative number and it has to be 12. So this line that I've written here, this whole thing, you actually don't have to write if you can do some of this in your head. So what I'm saying is, when you do questions like this, feel free to go straight to the line that I'm about to do here, where you can work out your a and your c. So you could jump straight to this. Oops, that's got to be -12. That's an x. And that's equal to the cubic you've been given. Right, so the only unknown we've got here is b. And so how would we find b? Factorizing this out, expanding this out to solve for b. Again, a technique I talked through in another video was a quick way of solving this, thinking about where would your x squared term come from. It would come from this x squared term multiplied by a constant, and that would give you a -6 there. Or x squared would come from this x term multiplied by that x term, and that would give you a b. Where would your x term come from? This x multiplied by the constant, and it doesn't matter which order you write these in. Or an x term would be this x term multiplied by that constant to give you -3b. And then the constant term is 36, ... And therefore, we need to solve for b. So we would equate that to the x squared term, which is up over here, or you could use this equation here. Either is fine. So we have to put it equal to -1. And so we have -6 plus b is equal to -1. I'm running out of room on my iPad, so I'm going to write the answer here is 5. And you could check that by subbing that one in there. So now we know our b, but we're not finished yet. We have to substitute that into the quadratic and keep going. So by substituting that back in, we would have our cubic written in this form. So we've substituted in our b value of 5, and we have to find the remaining solutions. So that means we have to factorize this quadratic here. Any method you know how to use for solving quadratics, feel free to use the quadratic formula if you like, but it might be quicker. Just a refresher, using a cross method to solve this, you might look at 12, you might look at 6 and 2 or 3 and 4 as your factors. You might start with 4 and 3, noticing that 12 is negative, so one of these has to be negative, not both. And you might play around, okay, if I do this as positive 6 and that is negative 4, that's going to get me positive 2. That's not 5, so that's not going to help me. What if I tried 2x and x and I switch them around, 3 and a 4? That way 2 multiplied by 4 gives me 8, subtract off 3, that would give me the 5. So reading horizontally, they are your linear factors. Rewriting that. So going back to read the question, when asked to find the remaining solutions come from here. So let's write that out. Our remaining solutions are x is equal to 3 over 2 and negative 4. Although you could just write x is equal to 3 over 2 and negative 4, I find it a good technique. If you've been asked in words a question, you should answer in words. Get you used to how you communicate your maths. And the second and final one here is if we're asked to find to 2 decimal places the solutions of this. Now, it hasn't told you which technique to solve for that, so feel free to use technology. The 2 decimal places probably implies that, but it's fine to use technology if it hasn't specified to find it algebraically. So I've got some screenshots of a graphics calculator here. You would put this into graphing mode as one option. There's other menus that you could use. I always like having a visual of it though as well. A standard window should be fine. Let's see what we get. Yep, so that will give us our solutions, and the solutions that we're after are what? Visually, what will they look? What will they be? There are x-intercepts. So the 3 solutions for this cubic. And to do that, we would do a G-sol, finding the roots here. And here we are. We've got negative 0.68, 2 decimal places, remember. We've got 1.3 rounding to 6 and 4.32. And those written out are there, approximately equal to, because we've rounded. Excellent. Okay, join me next time for 4E, graphing cubics. Thank you.